Totally cool. Okay. So we're going to talk about completing the square. You guys all know how to do it, right? You're all pretty well versed in completing the square, right? And at this point. And we're going to I think just to warm up our brains, we're going to just do one really fast, right? And just so that we can make sure we're all on the same page, because we're going to do something a little harder in just a second using the concept of completing the square. So, if I had something like this, 3x squared minus 9 equals negative 12x. Okay? And I said I want you to solve this by completing the square. First of all, before I begin, how do I want to set it up?
In quadratic.
What do I want it to yes, I want it to be in quadratic form, equaling 0, right? Mm-hmm. It's always best to start with that. I mean, you can eventually, as you get comfortable with these, might not have to do that. But in the beginning, if you always have it equal to 0, you always know what to do after it's equal to 0, right? It's really easy. So, don't you agree that has to get over here? So I'm going to add 12x. Add 12x, right? And so that gives me 3x squared plus 12x minus 9 equals 0. All right, what do you have to have for completing the square? What is the number one rule you have to look at? South.
The a needs to be 1.
The a needs to be a 1, right? So first thing we do is we divide everything by 3. Now notice I don't have to factor out a 3, right? It's because it equals 0, like it's still going to be 0 on that side when I divide it by 3, right? It's awesome. So the 3 actually disappears. It's awesome. So you just divide everything by 3, everything by 3. And then we have x squared plus 4x minus 3 equals 0. Wow, much easier, much easier. So now we've got to solve this. So to complete this square, what's the first step we have to do? So Alex.
Half of 4.
Wait, what's the first step before that?
Oh wait, move the 3.
Move that negative 3, right?
To both sides.
Because you are going to you want this space available for you to create the perfect square, right? So you got to get this out of the way. That's in the way. So we're going to add 3, draw our line. We've got x squared plus 4x plus space is equal to 3 plus space, right? You guys agree with me? Now we're ready in our space to put something. So now, Karen, what am I going to put in the space? How am I going to find that?
You're going to find half of 4,
right?
And then square that.
Okay, and half of positive 4 is positive 2. I like to put a circle around it because that helps me factor really fast, right? So 2 squared is 4. We're going to add 4 to this side, add 4 to this side. And so then I'm going to factor this. Factors of 4 that add to 4. 2 times 2, 2 plus 2, right? Ah, look, it's right there. So I could have just looked at that. X plus 2 squared is equal to 7. Now what do I do? Test. What's the next thing I do? From here, square root both sides. Okay. Square root both sides. So that gives me x plus 2 is equal to...
Square root of 7.
What? Say it again?
The square root of 7.
What are you missing?
Plus or minus.
Yes. Plus or minus is very important. Plus or minus the square root of 7. And then my final answer, I want to say x equals, not x plus 2 equals, right? So I'm going to just subtract 2. Don't ever put the subtract 2 under the 7, because what will happen is you'll think you can have the square root of 5. That's not possible. You can't do that. So x is equal to negative 2 plus or minus the square root of 7.
Oh my gosh.
Right? So, and we can just leave it like that unless
You asked.
I need to know for some reason what it is. Now, what did you just solve for? Raise your hand. Raise your hand. Raise your hand.
Create something cool.
Hindu, what did we just solve for?
The x-intercept.
We know that this is this going to be a smiley face or a frowny face?
So it would be a
Frown.
smiley.
Smile.
Look up here.
Smile.
The A is positive, right? So it's happy, right? Positive. So we know it's going to cross at these 2 points. The thing is, if I had to graph this, I would have to get out my calculator and figure out, well, what is the square root of 7? And add it to the -2 and then subtract it from -2, right? So I could know it's something here or here. You know, I mean, I'd know where it is on the x-axis. But that's what you found. You found the x-intercept, right? The x-intercept is also called the zeros. So when y is 0, it's what is x is. It's also called the roots. There's lots of terms that they use in math. Roots, zeros, x-intercepts. Okay, now that we just sort of warmed up our brain, we are going to do something a little different.
Oh. Is that right?
We are using this process. Every time we get an equation and they say, please solve this using completing the square, we have to set it up equal to 0, and then we have to complete this. We have to move things over. We have to divide by whatever, divide by a, and then we have to complete the square, and then we have to take the square root, and then we have to do all this stuff every time for every equation. So mathematicians started to say, wait a minute, could we just use the formula of y equals ax squared plus bx plus c, which is, or actually ax squared plus bx plus c equals 0, right? Use that formula and complete the square with the formula. And then we might get down to the bottom, it'll have a formula
Oh, and then you could plug it
that
in.
could say, then you could plug everything in. Isn't that cool? Do you see does that make sense to you? That will actually complete the square with the formula, not with a normal equation. The formula that has a and b and c, right? And we'll get down to an x equals something, and then we can just plug the stuff in. It would be so much faster. So that's what we're going to try to do. We're going to be inventors today. Mathematicians. Mathematical inventors. So, we're going to start with ax squared plus bx plus c equals what? 0, right? In order to complete the square, it always has to start with, we want to get it in that order. Now, what is, this is why we did that first problem, just to remember how to complete the square. Now, because this is going to be harder, because we don't have numbers, we have letters, right? So it's going to get confusing. What's the first thing I do? Karen?
Move the C.
Not quite. I could do that. I
Oh,
could do
divide by
that.
A.
Yeah, because
Yeah.
A is
Right,
not,
remember?
is not 1.
A has to equal
Like,
1
could
first,
be.
but we don't know if it equals 1. So we have to assume it doesn't equal 1, right? So we've got to divide everything by A. This is going to make things look a little confusing, right? Oh dear, because we're not going to be able to cancel anything out. So, we could cancel that out though, look at that. So that gives us now, we've got x squared plus bx over a plus c over a is equal to 0. You guys agree with me?
Wouldn't it be A though?
What?
0?
Well, 0 divided by a is if you had 0 in the numerator, your answer is always 0, right?
What
Okay.
if A is 0?
So it
A
is
is
0.
divided by 0.
What if A is 0?
But if you had a up here and 0 down here, it would be undefined
I
because
know,
it's
but what if A is 0?
But technically it's, I hate 0 to 0.
It can't be, because then you wouldn't have an x squared. See what I mean? Because 0 times x squared, then it wouldn't be a parabola.
It has to be 1.
See what I mean? So, okay. So now what's this next step? We've taken our first step, we've divided by a. What's our next step?
Get rid of C.
Get rid of c. In this case, it's that, right? So we've got to get rid of it. We're going to subtract c over a.
Figured it out.
Subtract c over a. Okay, draw my line. I have x squared plus bx over a is, you know what, I'm going to actually put plus, and I'm going to leave a space, equals negative c over a plus space. Okay? You with me so far? So we have a is 1. We've moved our c over. So we're now ready to find our perfect square on this side. How do we find it though?
Let's do that.
Divided by 2.
Wait, question. Liam.
How do we divide that by 2?
What?
How do we
Just
divide?
multiply it times 1/2.
How do we divide? Okay.
I didn't divide anything by 2. Oh, this, you're saying. Oh, how do you? Right.
Multiply it in half.
Think about it. Yeah, like think about it. If you had 10 and if you divided that by 2, oh actually we have a fraction. Let's say you have 1/5 and you wanted to divide it by 2. That's dividing by 2 over 1, right? And when you're learning how to multiply, how to divide fractions, you change it to a multiplier. So it's 1/5 times the reciprocal of that, 1/2. So really, dividing this by 2 is the same as multiplying this by
So
1/2,
it'll end up being,
right? So
Well,
what
it
is,
is B.
so I've got to multiply this, well, let's not do it there, sorry.
no, yeah.
Let's just do this. Let's say 1/2 times
B
b
over A.
x over a is
No,
equal
not the
to,
X, right? Because we're only dividing the B. Isn't that correct?
we're only, oh, right. Thank you. We're only dividing b. So what do we have?
So you have B over 2A.
We have b over 2a. So that's b over 2a, right?
Where'd the X go?
Because, well, like, remember if that were 8x, you take half of 8,
Oh.
right? So this is, okay, so this is, would you all agree with me? That is half of, I'll just write my x over here so that it's,
It's bigger than that.
does that make sense?
That's almost.
That is, what?
It's bigger
almost
than that
the
though. It's not half.
symmetry formula.
Well, actually, it's smaller because the denominator is bigger, right? Right? It's just reversed that way. All right, so then what am I going to put here? I got to do this
Oh, you have to
squared,
do that
right?
squared, yeah. you
So
have
I've got to
then
square
parentheses
both top and bottom. What would that be?
B squared.
B squared over what?
4A squared.
4a squared. 4a squared. Now I added it to this side. What do I have to do to the other side? Same thing, right? So I got b squared over 4a squared. Okay, so this is getting confusing, isn't it?
No.
Right? Really confusing.
No touch hole.
But the end goal is going to be worth it. Trust me. Because we're going to have this amazing thing that we can then use to plug things in. All right, so now, what's the next step?
Would you
Clayton.
do X plus B over, or no, X plus, yeah, B over 2A, and then
Squared?
squared.
Yes! Okay, so we're
equals
factoring
C.
this. So we're going to say x plus this, half of your b, which is this, b over 2a squared is equal to,
Would you add those together?
now we have this thing. Now this is a problem. Look at this, guys. What is, we have, would you agree with me, we have two fractions and we're adding them together, and what do you have to add them together?
Like,
like
bottom.
terms, right? No.
Like denominator.
Yeah, common denominators, remember? Right?
And they do.
This has an a, this has 4a squared. What would I have to multiply this by so that I have common denominators?
4A.
4a, right? You guys see that? And then it would be 4a squared. All right, so I'm going to have to do this times 4a, right? So if I did that, to simplify that, let's just see what that would give me. So we're going to have minus, and then 4ac, and then under here we have 4a squared plus b squared over 4a squared. So since I have the same denominators, I could just combine the top, right? You agree with
C
me?
plus B.
So I could combine the top. I'm going to put my b squared first, okay? Because, you know, typically you put your squareds first, you know, your higher exponents first. And so I'm going to do,
This is beginning to look very familiar.
it's starting to look familiar. So look at this. We're going to have, now, if I put them all over 4a squared, it's all going to be over 4a squared. Upstairs, it's going to be b squared minus 4ac.
Oh my god!
Are things starting to look familiar?
The quadratic?
Oh my gosh! But how did we get there from here? Okay,
Wow.
we got some work to do
And
still.
see,
So what do I do now? Now that I have
Now you need to
factored
factor both
this,
sides.
remember completing the square, I created a perfect square here. Now I
Okay, square root
factored
both
it.
sides.
Now what?
Square root both sides.
Square root both sides. You guys agree?
Oh my god.
Now watch, we're going to square right, yeah, that's exactly right. Oh my god, right? Square that, square root that side. Now
Oh my
if I
God.
square root this side, think about it, it's the same thing as squaring both top and bottom. I'm going to do them separately like that.
And
Okay.
that's just 2A at the
So
bottom.
now I'm going to write x plus b over 2a
Which
equals, right?
that
That,
B over 2a is almost the x.
We already have
you're right, you're right.
Negative b over.
Okay, now
We
watch.
already
Now
have
what
the
do I have to
quadratic
put here?
formula.
The square root of b.
I have to do plus or minus,
Oh my god.
right? The square root of b squared minus 4ac
And then when
all over, what is the
2a.
square root of 4?
2a.
Yeah, so 2a. Square root of 4 is 2. Square root of a squared is
And then you
a.
have like terms over there.
Right?
And
You
then
with
you
me?
have negative b plus or minus square root
Makes
of 4
sense?
minus 4ac over
Okay,
2a.
so now we got to subtract this, right? We want to say x equals. We're almost there, you guys. This is amazing. So look, we're going to subtract b over 2a. We're going to subtract b over 2a. So
X.
if I did that, I would get x. Is this still visible on there?
Negative
X is
b.
equal to, we've got negative b, I'm going to keep them separate for a second, 2a, and then plus or minus the square root of b squared minus 4ac all over 2a.
It's a quadratic formula.
Now, do I have common denominators?
No.
Yes?
Yeah.
So I could put them all underneath, I could put all this stuff upstairs underneath the same 2a. And then, I will have, if I did that, I would have x is equal to,
X negative b.
I would have negative b plus or minus
The square root.
square root of b squared
minus
minus
4ac
4ac
all over
all over
2a.
2a. And what is that called?
Quadratic formula.
Quadratic formula.
Oh my god.
That's awesome. That's scary. That's what I got.
Is that cool? That is how the quadratic formula was invented. Somebody just like us, we figured out the completing the square and we thought, oh my god, let's instead of have to do this every time, let's have a formula that we can just plug stuff into, right? And so completing the square is the parent of the quadratic
gave
formula.
birth to the
So
quadratic
now,
formula.
yes, it gave birth to it, right? Sorry,
Quadratic formula.
which part did I erase?
At the bottom part.
All right, so I don't know where I was.
I need the bottom part.
You need the bottom part?
It's
Where do I said, okay, this is x, okay, all over 2a. This was x plus equals that over 2a. Okay? And then I said, then I subtracted b over 2a, subtracted b over 2a, and then that gave me x is equal to minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And since I have this common denominators, I can just combine the numerators, right? And I get that wonderful thing. So what can I erase? Can I erase from here up?
We just created a
Is
quadratic.
that okay? From here up?
yes.
So what was the point
No. I thought you meant right above that. Okay. Whatever.
Yeah.
All right.
I mean, Gary.
So yeah, if you didn't get that whole thing, it's not critical. You can, I think I have a lecture, well, you will, I have a lecture now, right? Yeah, I
I
have a
don't
lecture.
get it.
So you can go back and add that to your notes if you want.
So,
But I just don't have a lot of time, so I just want to cover one more thing.
what was the point of that?
The point of that was to show you where the quadratic
How to
formula
create
came
something
from.
cool with completing squares.
Yes.
Right?
Yes.
Oh my
Yes.
god.
So now I want to now.
So cool.
So we haven't done much with the quadratic formula this year. Last year we
We
did a
haven't
little
done
bit.
anything. We haven't even
Right.
mentioned it.
So if I gave you a problem like uh, 2x squared plus 3x minus 10 equals 0. It has to equal 0, right? It has
Plug
to
it
equal
into the
0
quadratic formula.
before I know what my a, b, and c are, right? Is that clear? I have to know it has to equal 0 first. If it equaled 2, it wouldn't work. I'd have to subtract 2 from both sides to have it equal 0.
Is this
Then I know, I gotta remember my a and my b and my c.
Are we gonna plug it
So,
into the quadratic?
yes, so
Oh.
a is equal to what?
2.
2. b is equal to what?
3.
And c is equal to what?
Oh, we did this last year.
Negative 10. Good. That sign goes with this with the number, right? Okay, so now we're going to plug that in. So if somebody asked us to, you could get 3 different things. People could say solve. Solve means find the zeros. If you have a quadratic formula and they ask you to solve it, they're asking you to find the x-intercepts, right? So solve, they might ask you to solve it. They might ask you to find the zeros. They might ask you to find the roots, right? This is all the same thing. Or lastly, they might ask you to find, to find the x-intercepts, right? Those are all the same thing. Solve this quadratic equation means find the x-intercepts. Find the zeros means find the x-intercepts. Find the roots, find the x-intercepts. All right, so now we're going to do it. X is equal to negative b, negative 3, plus or minus the square root of b squared. So 3 squared is 9. Minus, now this is where, this is important. This part, I don't recommend you do this in your head, right here. Do that in your head, that's fine. This is always going to be a positive number. Even if b was negative, if that had been negative 3, it would still be negative 3 squared is positive 9, right? That number is always positive. But this number, because of this minus sign here, people mess up a lot. Top math students mess up. It's not, I'm just saying everybody should do this. They should write 4, parenthesis, a is 2, parenthesis, c is negative 10.
Would it be
Okay.
negative 80?
All over 2 times a, which is 2. 2 times 2 is 4, right? So yeah, this is where people mess up. So how many negatives do I have?
1.
I have 2. So multiplying them together, they become a positive, right? So I'm not going to have any negatives. This is going to become positive.
It's going to be
So
9.
we got x's, negative 3, plus or minus the square root of 9 plus 4 times 2 is 8 times 10 is 80.
That's 89.
Okay, that's 89 all over 4. So we got x is equal to negative 3 plus or minus the square root of 89 all over 4.
89 is nothing squared.
And now I ask myself, can I simplify any further?
No.
Does anything go into negative 3 that goes into 4? No.
1. You can
And-
multiply it by its reciprocal.
But I would, let's say it was. Let's say that was minus 4 plus or minus the square root of
It's
89
not being
over 4.
multiplied.
I still could not do that. I could not cross those out because of this plus or minus sign. The only time I can cross out this 4 is if there's a 4 or something in both of these that I can take out. Does that make sense?
So then is that the answer?
Yeah, so that's the answer. That is the answer. And if you had used completing the square, that's the answer you would have
It would
gotten.
have taken too long though.
If you had used completing the square, that's what you would have gotten. So, so it is a shortcut. Some math teachers will say, always try factoring things first. You know, your tool belt of your tricks on factoring. But if you can't figure it out within 30 to 60 seconds, go right to the quadratic formula, right? So quadratic formula is the result of completing the square. Completing the square is something, it's a process, it's a very powerful process. It always, always works. The quadratic formula, since it was born from the completing the square, it always, always works. You can always get an answer
We should do that
through,
problem completing the square.
we could. It would be hard because look,
Yeah.
the reason you have a
Then we
denominator
just end up with
is
1.5.
because if you divide everything by 2, 2 doesn't go into 3, right?
Then it would have to be 1.5.
So then you're going to have a fraction.
And then you'd have to get half
some
of
sort.
1.5
Right.
to square, and then
Now, if you had completed the square and chose to use decimals, it might look a little different than this, right? Because you would have decimals instead of fractions. But fractions and decimals are the same thing. They're just different languages for the same thing, right? So it might look a little different, but it would be the same value because it would just be decimals. So anyways, that's it. So this always works. Now, if I asked you to find the zeros on something, if I asked you to find the zeros of this, x squared plus 2x minus 48 equals 0, would I use the quadratic formula?
No.
no.
Would I use completing the square?
Yeah.
What?
Wait.
Or would I try to factor it?
You could do any of them.
The first thing I would always try is, are there factors of negative 48 that add to 2?
Yeah.
Let's see, 6 times 8, they're 2 apart.
Whoa.
So I could do 8 times negative 6, that gives me positive 2, doesn't it?
And then that saves
So then
all
I
that
could just
trouble.
factor it. X plus 8 is equal to x, whoops, not equal, times x minus 6 equals 0. That
And you
means
have 6
X
X
equals negative
plus
8.
8 is equal to 0, or x equals negative 8. Or
X equals
x
positive
minus 6
6.
equals 0, or which means x is equal to positive 6. That's an or, believe it or not. Okay, so yes, you have learned all these tricks. Use them when you can. But if after 30 to 60 seconds you can't figure out how to factor that, go right up to this and do this.
And what's quicker, the quadratic formula or the completing the square?
Well, this is much quicker than
no, but if
using
you
that.
can't do that, which one's quicker? The quadratic formula.
Completing the square of this? Oh, this is quicker.
Okay.
Definitely quicker.
So we should
Because all you have to
complete
plug
the
it in,
square
do
anymore?
is plug it in, and
Yeah.
it's it's there. Because completing the square, I've been kind of nice. I've given you fairly easy, you know. But if I gave you ones where everything was a fraction, everything was a decimal,
Yeah, and they
it could be
nice.
difficult. All right, so that's the end of the lecture.